Hello, welcome to the Azure Cosmos DB Liftoff series. My name is Nick Larin. I'm an Azure Cosmos DB for Postgres product manager. Today, we're going to talk about scaling our distributed Postgres database in Azure, scaling reads across multiple Azure regions, and using Postgres cluster read replicas for disaster recovery. Before we begin, let me quickly go through the key terminology we use in our distributed Postgres. Postgres cluster may have two types of nodes, coordinator and worker node. Each node is a managed Postgres server with Citus extension running on its own virtual machine. Coordinator stores cluster metadata and is the cluster node that your application connects to as it would to any other Postgres database. Coordinator acts as a dispatcher for distributed queries and writes directing them to the right nodes in the cluster and aggregating read results coming from individual nodes before sending it back to the application. Worker node stores actual data in the form of shards, and shard is a Postgres table on a worker node that contains a subset of rows for a given Postgres table. We talk about sharding when we need to distribute Postgres database, or in other words, divide data among the nodes by putting it in individual shards. Distribution column, also called distribution key, is used to assign table rows to specific shards. Choosing the distribution column for each table in your database is one of the most important data modeling decisions. It determines how data is spread across the nodes in a cluster and hence performance of the distributed Postgres. Now that we reviewed the key terms for distributed Postgres, let's take a look at the scale-out capabilities. The most fundamental ability of Azure Cosmos DB for Postgres is scale-out. You can start with a single node Postgres and shard your Postgres database by adding more nodes to the cluster in future. Let's take a closer look at what defines single and multi-node Postgres. A single node Postgres is what we offer in as a part of the Azure Cosmos DB is a robust and full-featured managed Postgres. It is built using native open-source Postgres. We support all major Postgres versions that are maintained by Postgres community. The major benefit of using native Postgres that is not a Postgres fork in our managed service is how fast we can deliver innovation in Postgres database engine and compatibility with rich Postgres ecosystems, including extensions. Then, our single-node Postgres offers a broad range of features that you may expect in a managed relational database service, from compute and storage scaling to high availability to network security options, including public and private access, to cross-region read replicas that we're going to talk more in this presentation, and more. One of the distinctive features of our single-node Postgres is ability to define data distribution model even before you need all power of multi-node cluster. To do that, you would need to select a column to be used as a distribution key and create distributed tables. That would define shards and rules for possible future multi-node cluster. Doing that is easy before you ingest significant amount of data into your Postgres database and makes your workload ready for future scale-out. So how exactly transition from single node to multi-node works? When you outgrow a single node or simply need power of distributed Postgres, you can transition to multi-node Postgres in two steps without downtime. First, you need to add worker nodes. Once added, worker nodes are empty, so you need to move some data to these nodes. For that, you need to do so-called shard rebalancing that would move chunks of data to the worker nodes with zero database downtime. Your application continues to work as before, as connection string stays the same, and all features that you configured before for your single node Postgres will continue to be there in the multi-node configuration. Once data is moved to worker nodes, your transition from single node to multi-node Postgres cluster is completed, and you can enjoy benefits of multi-node Postgres performance. Here's how transition works. On this slide, we're starting with a single node on the left that combines coordinator and worker node roles. We talked about data modeling on single node by choosing distribution column and creating distributed tables. Once done, it is just about adding worker nodes to your single node with few clicks in Azure portal and rebalancing shards, so that data is moved to the newly added nodes. On the left side, you can see a single node configuration that is transitioning to multi-node one on the right with one coordinator and 3 worker nodes. After transition to multi-node cluster, your application continues to connect to coordinator node for reads and writes with elevated performance delivered by multiple nodes. When your data and performance needs grow even further, you can keep adding worker nodes to your multi-node configuration with zero downtime. Let's take a look at a live Postgres cluster that has outgrown single-node Postgres and needs to become a multi-node one. While scale-out helps to keep growing your cluster with zero downtime, all of it is happening on one cluster. What if you have a very demanding read consumer, such as hundreds and thousands of users refreshing their analytical dashboards? Cluster read replicas may help in this case. You would create a read replica cluster in the same or another Azure region and point those readers to that replica to offload reads from your primary Postgres cluster. You can create read replicas for single node or multi-node clusters. Let's take a look at what defines read replica clusters. First of all, it is a synchronous replication. It means the transaction can be committed on the primary Postgres cluster before it's replicated to all replicas. That improves write performance on the primary cluster, but also means that you have so-called replication lag on replicas that you would want to monitor using Azure Monitor metrics. Each read replica has its own connection string as well as certain configuration settings, such as compute configuration. It means that you can have a more or less powerful read replicas compared to your primary cluster, depending on the actual compute needs on these replicas. You can create up to 5 replicas in any supported Azure region. Last but not least, you can create read replicas for a read-write cluster, but you can create a replica for a replica, or so-called nested replicas. In addition to read scalability, read replicas can be used for cross-region disaster recovery when you need to switch from your primary cluster to another one in case of region unavailability. Read replicas can also be used to move your Postgres cluster from one Azure region to another. Let's take a closer look at disaster recovery with read replicas. So a read replica in Azure Cosmos DB for Postgres can be promoted to an independent cluster available for reads and writes. You can break replication relationship between a read replica and its primary cluster at any time. As replication between primary cluster and its replicas is asynchronous, there is often replication lag that can vary across nodes in a cluster. To decide on whether you would like to promote specific replica to an independent cluster, you may check replication lag on all nodes in the replica cluster using Azure Monitor metrics. Once read replica promotion is initiated, it cannot be reversed and would take a few minutes to complete. Now let's take a look at what we discussed today. We talked about single node and multi-node Postgres clusters and how to transition from single node to multi-node clusters, how to set up read replicas of distributed Postgres database in different Azure regions, and finally we talked about how to use read replicas for disaster recovery. If you would like to learn more about Azure Cosmos DB for Postgres, use this short link. Thank you very much for your time.